Live launch is always exciting. Hello.
Hello.
And your name is Michael, is that correct? Or should I call you Mike, or do you go by Mr. M? Are you
Michael is fine.
How should I talk to you?
Yeah, Michael works well. That'd be great.
You are a researcher and a scientist based here on the Fairbanks campus of the University of Alaska Fairbanks.
Yes.
Which unit? Where's your lab set?
We are up in the Akasofu building, which is the International Arctic Research Center, or commonly called IARC, and I work for an organization called SNAP, which is an acronym for the Scenarios Network for Alaska and Arctic Planning, which focuses on lots of different things related to climate change and adaptation and resilience. And I work a lot on data problems, particularly ones in the geospatial realm.
Science is all about data. I mean, you can't do anything, you can't see what's working, predict what might work without that data that comes in. Is there too much data in your life? Do you have to take data breaks sometimes?
You know, there's a lot of great tools out there for us to work with the, seemingly never-ending sea of data that keeps coming in and that's available. The hardest thing that I've found has been shifting from different paradigms of data to different things for different projects, and then kind of the never-ending crossover of where things kind of are the Venn diagram of meeting up, and then other times they're not so much. So getting your head into the brain space of each individual data project can be somewhat of a little bit of a step, but it's not usually too bad.
Like I got this data set. Oh, it's not for that project I'm working on. It's for the that I've got. That's why the graphs weren't working right.
Right, exactly. It's all about that plug in the right thing.
in the first part of the of SNAP is the scenarios. Is that imagining things that might happen? Is it extrapolating things that are going on? What are the scenarios that you're looking at?
So the scenarios are rooted directly in the International Panel on Climate Change, Intergovernmental Panel on Climate Change, the IPCC, their data outputs for the last run of all those data models, which was called CMIP-5. So there are several different realization pathways of potential futures given different types of forcings from human interactions into the atmosphere, and then solar radiation and how that interacts in that changing atmosphere, to give us slightly different futures based on how we extrapolate that information from a known historical period into a place that would be a model realm, looking at that kind of variability. And our scenarios are trying to say, okay, let's look at all the different scenarios of change and then find places that are always changing, regardless of how we look at the future. And those places are places that don't have a very high resilience factor, have an issue with, a lot of change happening in short periods of time. And in those places, we can start to look at different features on the landscape, be it, permafrost and snow, or animals or other types of plant species and fire, and how those things might be exacerbated or changed by some of those changes in those particular areas of always changing. I know I keep saying change a lot, but it's kind of the world we're in.
Yeah.
But it's basically taking all of the best science from a huge envelope of possibilities, and then saying, okay, if we look at all of these possibilities, we always tend to move in a warmer direction, or in a direction with decreasing permafrost or changing sea ice. Therefore, we should focus on those things a little bit more to try to understand more about those dynamics, which will allow us to hopefully make better decisions in the future, and then be adaptable into the changing world that we're experiencing in terms of environment.
And there are individual scientists, specialists all over the Fairbanks campus that are doing that research, collecting that data to send to you to do these future modeling and things like that, to give you that information that you need.
Absolutely, and around the world too. We get to work with an amazing group of researchers the world over, from Europe to Asia to Africa, and everybody is trying to find the best ways forward given the types of data we have, and then the best practices in the science to produce the best outputs. And it's kind of that old adage of, you always hate to say it, but all models are wrong, some are useful, and we're trying to find that useful piece to the puzzle where it's not wrong when you have 50% new information. We actually have the glass is half full, not half empty. And so the more and more that we learn about that, the more we can add on to that known piece to the puzzle, and then we can make better decisions.
Are scientists optimists then? It's like, it's half working.
Yeah, I think in the modeling world, we definitely are optimists. Yeah, in that sort of a way, just because we kind of have to, nitpick at things to be able to get model outputs that are following best practices, allowing the data to shake out within the algorithms as objectively as possible, and then making better decisions with those new extrapolations about how we should move forward in a changing environment.
The more and more I talk to the scientists, and I've talked to many over the past years that I've worked here at the university, I'm always surprised and amazed at the collaborative nature of science. It doesn't matter where you're based, what flag that you work under. Scientists love to work together to further all of humankind's understanding of our planet.
Absolutely. Absolutely.
And a big part of that is the community, and that's sort of what's going on this week. There's a big Arctic research open house happening up here at campus, and you're going to be a part of that. You're going to be talking about some of this stuff that we've been talking about today, with people just coming in and hanging out at your table.
Yeah, absolutely, and we hope there's a great turnout from the public. I think there's a lot of relevant data tools that we've been producing here at SNAP that are particularly useful in this time of year, with the fire season kind of entering into full swing. We had a little bit of smoke in Fairbanks over the weekend, so I think in people's minds there's we want to understand a little bit more about where fire has occurred in the past, where it's occurring now, and then also to kind of get an idea of how close to town are some of these fires. So we have a few web applications that I'll be showing off. One is related to fire, taking the fire polygon data from the Alaska Interagency Cooperative group that produces all of the fire perimeters and then shows lightning strikes and things of that nature. And we've put that onto a large web map that's produced here at SNAP under mapventure.org. And it's a fire map that allows you to look around at, the kinds of fire that have occurred in the past 10, 15, 20 years, and then also what's happening now, and to give people an idea of the spatial orientation of fires, and then also to see that we're actually kind of experiencing things that are a little bit even outside of the modeling realm, where we're seeing areas reburn in less than 100 years, which we've always the old adage was we have a 100-year succession cycle, and it takes about 100 years for a forest to turn into something that would be highly flammable again. But we're actually seeing that within, the fires that are happening down in Delta right now are actually happening in areas that are that burned within the last 20 years. So it's a reburn, which is an interesting piece of the puzzle, and was partially unexpected.
I'll add the link to the post. I go back and edit it.
Excellent.
This fire information is a great example of how science reaches outside the lab and directly impacts the lives of people who are trying to get out and go camping, or take their visitors to see the Chattanooga or wherever they're going. Like, you can use that information for planning your summer.
Absolutely. And then you can combine that with what you're seeing with weather from your AccuWeather and weather.com and things like that too, to kind of get an idea of where the wind direction is going to be shifting in our way towards the campsite or the place that we're going to be hiking this weekend. Is that going to be something that'll be impactful, or maybe we're lucky and it's going the other way and it's not going to affect us?
It's going to be perfect. Hey, the rocks, let's go there because the smoke's going the other way this weekend.
Right. We have to go the other direction. But yeah, I think what it'll give people is a little bit of an idea that we're already experiencing some big fires early in the season, and as we see changes in lightning patterns, and a drier ecosystem, we're probably going to see a lot more fires pop up. And along with, I'm sorry.
No, you go ahead.
And along with the fire angle, we also have another application that I'll be showing too, which is looking at change through time for different communities. And it's called the Community Charts tool from SNAP, and you can look at your community of interest across Alaska and Western Canada and see what kinds of changes are happening from the climatological record in what is considered the historical period, and then look at how the 30-year averages of data change through different epochs in time into the future. So different 30-year blocks, say from the 2020s onward, or the 2010s onward, 2050s onward. So you can kind of get an idea of how things are shifting in terms of temperature precipitation regimes, which temperature precipitation are two very important drivers of fire. And so if we're seeing a lot of increased fire activity and we're seeing a decrease in precipitation and increase in temperatures, we might see more fire activity, which is an interesting place. Trying to link both the fire data, which is observed, to this climate information, which is both observed and extrapolated.
And also, so people that are out there, they're learning about these things, they come to talk to you about that this week, then they can take that information and they can communicate it to the lawmakers, the policymakers that they're working at. This is important stuff. I want these communities, you can use this tool. And so the people who are in these decision making have this good science to use. They know the community wants them to invest resources in there. And that's how normal, everyday people can make a difference to help mitigate the effects of climate change.
Absolutely, and then also adapt to the changes that we're going to experience, regardless of how we, make better decisions in the future. So it's about that adaptation wrinkle of the mix right now. Of okay, we have a change in the climate that's going to affect a camping day or something like that, which is or even our food growing, things like that. I mean, there's a lot of ways that we, as citizens and as people who are not necessarily farmers or scientists, are interacting with the world in ways that we have to make adaptive changes to the way we do things because of the changes that are occurring in the world. And that's kind of what we're doing on a more macro scale with SNAP, and looking at those scenarios of change, and then hopefully creating tools or continuing to make tools that make it easier for people to understand those changes in a place that they're familiar with.
One of the great things about open houses like the one that's going on this week is people can bring the young members of their family, their friends, to sort of keep fostering that interest of science, because kids are so curious about the world. They are original scientists. They're what I call early career scientists. You're 7 and 8 years old and you're figuring out how the world works. How do you keep them interested in science as they start to think about the rest of their lives? How do you maintain that fascination?
Yeah, it's interesting because I think it's a multi-pronged approach where it kind of involves an understanding of some, making sure we're giving the mathematical and programming and software tools that are necessary for you to be able to actually work with these volumes of data to understand the world from your computer desk, but also getting kids or continuing to have kids or young people out in the world experiencing changes in permafrost, seeing how permafrost degradation is occurring right here in Fairbanks. We can just, head out on the Steese Highway and see where the deformation is occurring on the hillsides right there. And there's people who live above there. So what does that mean for engineering? What does that mean for the future of human settlements? And then trying to link it back to what does that mean for the future of their community? That this is, we're a small town in a very far out place, and little changes like that affect us all, even if it's not our home. So there's a social dynamic, there's an environmental dynamic, and then get out and get your hands in the soil. Plant things, learn how the world interacts with weather and climate, and then you just kind of it gets under your skin, and you just want to be a part of it. I was out with my 2-year-old daughter all weekend, and we were just exploring the world, taking a look at bugs and fun things that are just kind of different, and then looking at things in a light of, wow, there's all these changes that happen in the world, from the wintertime where it's really cold and dark to the spring with amazing flowers and chokecherries and, roses and all these things to learn. And we live in this amazing, amazing environment here in Alaska that we can just really sink our teeth into and be in the laboratory of our backyard. And I think that's one of the things we need to realize a lot too, is that we're in it.
So the thing is, Thursday is when the open house is, and it's a few hours in the afternoon. You can come up here on the campus and you can see all of the cool science, or a representation of all the cool science that's going on. And outreach, things like this are so important. How do you balance that time, which is the most valuable resource out there? You've got all this data to analyze, all this work to do. How do you balance the time for taking some time out of it to do these outreach projects? How do you approach that?
Yeah, I mean, personally, I view it as just a part of what we do. It's kind of there's always an aspect of things that are not necessarily your work, but are important to your work, like having a clean workspace and things like that. So this is not in the same realm, but I mean, making sure that people see what you're doing with the people's money is not only important to me, it's actually something that I highly value. And I want to make sure that the best, bang for your buck, if you want to think about it in terms of a customer and producer kind of relationship, or is something that's very important to us here at SNAP, the university as a whole, and then making sure that we're providing the community with the best tools that are the most useful to them in the future. And I think we've been doing a really good job of that. But like everything, these kinds of outreach events allow us to interact with people that we don't get to communicate with every single day, and interact with the youth, and what things don't make sense. Like, does this web map even fit anything? Does it fit the need that you have in your mind right now? And if not, we can make changes, because that's the fun thing about software and data, is that it's malleable.
And it's a great collaboration between science and the community. And a community member might ask you a question that prompts you to take the next step of the work that you're doing.
Absolutely. Or we can find a way to collaborate too. Some of the best interactions and the best collaborations I've ever had have been with folks who are in the environment. Being somebody who's not originally from Alaska and having the privilege and love to be a part of this place for the past decade, I learned so much from every person that I get to talk to who was out on a moose hunt or a hike, or who has been living a subsistence lifestyle in one of the amazing communities here in Alaska. That we're all a part of this together, and this knowledge set, whether it's some weird way of storing data and working with data in the computer realm, or it's how we actually were living in the environment, are two very important pieces of the puzzle that have to be together in order for us to have a holistic view of resilience, change, and how we move forward as a people. And that's one of the things that I really appreciate about these outreach opportunities. And then anytime I ever get a chance to interact with the public is always the best.
One last thing before you go, there's going to be information about the event. You can go in there and click up all here in the post, but you work with data so much, and so much of your brain is in the computer. When you see the world around you, is it like you're in the Matrix and everything's just of data, like that tree is more than just leaves and branches?
It definitely crosses the mind. I wish I had as rich of an imagination to have that be the place that I was, but I think it's more of, I kind of see, or I learn about how to keep changing ways of building algorithms by looking at natural phenomenon. And then I understand a lot about what happens with algorithms and the way we store data, because everything maps back to nature. And so even the way that we refer to a lot of parts of the computer and things like that it follows a natural system. And so you can kind of learn a little bit more about the thing you may have been using for a long time by watching ants march across a road. It's kind of weird the way that your brain works, but those little things can sometimes bring a lot of clarity to what seems like a very complex and almost ununderstandable problem. And I really enjoy that.
Michael, thank you so much for taking some time to chat with me. I really, really appreciate it. Have a great time at the open house. I hope everybody who's watching will take their family and friends. Great for tourists. Come here, learn more about Alaska, like beyond all the stuff that you can do for the visitors. Bring them on up here and see some real science and take that real science home.
Absolutely. That'd be great. I look forward to seeing everybody.
Thanks, man.
So much. Have a great day.